Do you know what went wrong in the last tutorial? You might have noticed something weird when we sneak up behind the guard and shoot them. They just flash a question mark or an exclamation mark above their head, but totally ignore the attack. That's a problem, and we need to fix it ASAP. So, let's hop back to our trusty friend VS Code and go to the Guard Spawner Device API. Now, remember when I said in part 1 that we didn't need the damaged event? Well, I lied. Turns out, we do need it. Copy this code, then head over to our Guard AI Device verse file. Paste it in the onBegin function and set up the onDamaged event just like we did in part 1. So, what happens when the guard gets shot? This function will be called. Based on the comment above, the source is us, the player, and the target is the guard. As usual, we'll grab our guard AI first. Now, in this situation, when the guard is roaming and gets shot, the best thing we can do is switch them to the chasing state immediately. First, we'll check if the guard is in the roaming state. Then, we'll grab the target fort character, set it as the new target, and boom, switch to chasing state. Alright, let's see if the guard reacts to our shot this time. Awesome. He turned around instantly. Took only 4 shots, and he's already dead.
He's already dead.
A little weak, right? Let's bully him a bit more and see if anything unusual happens. Nice! Still working as expected. Oh wait, I just remembered. When the guard is in the attacking state, he's just wandering around randomly. Let's step up his game. How about adding a zigzag pattern to his movement? Here's the plan. In the attacking state, we have the guard and ourselves. From the guard, we get his position, and the same goes for us. Then, we can calculate the direction the guard is facing. After that, we'll get the unit vector from that direction. A unit vector points in the same direction but has a length of only 1 meter. To prevent the guard from moving in a straight line, we'll rotate his direction a bit, let's say 30 degrees. And voila! We'll move the guard to this new location. Now, let's jump back to our code, focusing on the move zigzag pattern function. First, we grab the guard's location by calling the getTransform function on the fort character. Then access translation and call it guard translation. We do the same to get the target translation. Next, we calculate the direction by subtracting guard translation from target translation. Before moving on, we check if both the guard and target are still alive. Then, to create the unit vector, we make a vector 3 using the x and y values of our direction. Since we're not dealing with vertical movement, we'll set z to 0 and call makeUnitVector. For the zigzag, we'll pick a random angle between -90 and 90 degrees and convert it to radians using the degrees to radians function. To rotate the unit vector, we need a rotation. We're rotating around the z-axis, so x and y remain 0, and z is set to 1. Then, we apply the calculated rotation. Each time the guard moves, we'll set the movement distance randomly between 768 and 1024 centimeters. After that, we calculate the move direction vector by rotating the unit vector using the rotator we calculated earlier and multiplying it by the distance we want the guard to move. We only change x and y here, with z staying at 0 to keep the guard on the ground. Next, we calculate the guard's destination by adding the move direction to his current translation. Then, as usual, we calculate the navigation target and make the guard move. Since our movement only happens once, we'll wrap it in a loop to keep him moving infinitely. And for safety, we add an exit condition using else and break to stop the loop when needed. Nice! Now he moves like Jagger. But I gotta say, he's moving a bit too slow, so the zigzag pattern isn't really obvious. We need to speed him up. So what should we do? You might think we need a movement modulator device and have to set it up, access it in the code, blah blah blah. That's a lot of work. But guess what? There's an easier way. Just one line of code. Let me show you. The navigation already has a built-in function called setMovementSpeedMultiplier. We'll use that to make him about 50% faster. But to add a bit more unpredictability, we'll use our good old friend getRandomFloat to set the movement speed randomly between 1.5 and 1.7 times his normal speed. Now, watch this. When he's roaming, he moves slowly, but as soon as we shoot him, he speeds up like crazy.
Tight!
Alright, it's time to implement a feature for having multiple guards per device. To make this work, the guard AI device will no longer handle running the state machine. Instead, each individual guard AI will take responsibility for that. We're going to need a little refactor here. First, let's copy almost all the code from the guard AI device, from here to the end, and paste it into the guard AI class. Don't forget to move optional target to the guard AI class as well. Now, we'll clean up and fix the errors. In the onSpawned function, we're setting up the guard agent, fort character, and so on. But since we already did that in the guard AI device class, we can safely remove it here and keep only the runStateMachine function. Next, in the runStateMachine function, we're already inside the guard AI, so that initial check is unnecessary. And since we can access the fort character directly, we'll remove any instance of guard AI wherever we see it. After that, the function looks much cleaner. We'll do the same thing for runStateOnly, removing all instances of guard AI, and we follow the same steps for roaming, chasing, attacking, and move Zig-Zag pattern. Oh, and here's the new onAlerted function. For this one, we only need the target agent and target fort character. Since we've already done the checks in the guard AI device class, we can remove that part here. Also, maintain focus isn't used anywhere, so let's remove that too. For onTargetLost, we need to change the state based on whether the target is alive or not. So we take target agent as a parameter, remove the unnecessary stuff, and clean up guard AI. For onUnaware, we know that the guard is unaware, so there's no need to check anything extra. Remove all the unnecessary lines. The onEliminated function isn't used, so we can get rid of that too. And for onEliminating, we treat it the same as onUnaware. Now for the onDamaged function. Here, we need target agent and fort character. We only need to check if the guard is in the roaming state, and then we clean it up like usual. Back in the guard AI device class, we're no longer holding just one guard AI. Now we hold a map of guard AIs, and we use the agent to access the guard AI map. In the onSpawned function, we first create a guard AI, then we add it to the guard AI map. If the addition is successful, we call the onSpawned function on the guard AI. Then we remove everything from runStateMachine to move Zig-Zag pattern. For the onAlerted function, instead of accessing just one guard AI, we'll get it from the guard AI map using the guard agent as the key, and then call the onAlerted function on the guard AI. We can also remove maintain focus. For onTargetLost, we'll do the same, get it from the map using the agent. Same for onUnaware. When the guard is eliminated, the onEliminated function gets called. We need to remove that guard from the map because, well, our good old guard is in heaven now. RIP, my friend. So, target is our guard. We'll create a temporary map to hold the remaining alive guards. Then, we loop through the guard AI map, get each agent and guard AI, and check to make sure the current agent isn't the one we just eliminated. After that, we add the alive guards to the temporary new guard AI map. Once the loop is done, we replace the old guard AI map with the new one. Finally, we'll refactor the onEliminating and onDamaged functions the same way. Like this. In UEFN, we increase the number of spawns from 1 to around 5. Ah, our first guard. Nice to see you again. Let's call up the others. 2, 3. Okay, 3 more. Wait, too many. Oh man, I suck at this. Whoa, there are way too many. As they say, sometimes the best defense is running away. Are you feeling overwhelmed yet? I'm already getting dizzy. Let's hide and see if they're still chasing us. Choo-choo, just like a train. Okay, this game's starting to feel unfair, and not much fun, right? How about we introduce another team? Wait, why is my gun pink? Whatever, I'll let them duke it out first. Why start a war when I can just show up for the chicken dinner? Looks beautiful, doesn't it? Alright, let's clean up the rest. Oh no, a good old runtime error? Long time no see, my friend. We've run out of memory. What's going on? Can I fix this? Just kidding. I knew this was going to happen before even making the tutorial. The issue is that when the guard is in the chasing or attacking state, if the target is eliminated by someone else, those states keep running over and over until it crashes. So we'll move the "Is the target alive?" Check down here, and if it's eliminated, we'll switch back to roaming state. We'll also do the same thing for the attacking state. Now, let's take them all out and see if the error pops up again. Everything seems fine. I hope. So, the basic combat system is now complete. What's next? Is this the happy ending for the series? Honestly, I've really enjoyed making this series, and I'd miss you guys if I stopped here. But I've got a little surprise for you. Want to bring custom animations to your guards like I did in my public island? In the next video, I'll show you how as a special thank you for helping me reach 100 subscribers. Your support means the world to me, and I couldn't have done it without you. I'm excited to keep creating and sharing even more awesome content with you. Until next time, goodbye.